In today's video, we're going to look at solving similar triangles. So we'll be solving for missing sides, given a variety of diagrams or sets of information. But just as a reminder, when we're looking at similar triangles, the order in which we compare our sides or figure out which sides are, compared in a proportion, the order is extremely important. And so a lot of times you may need to rely on the similarity statement or the names of the similar triangles that are given in order to make sure that you have things matched up. So real quick, let's review how we could do that. So I've given you an example. We actually have a bow tie diagram. And be careful with these. Sometimes they're twisted around on us. Sometimes they're straight reflected from each other. And it really just depends on what the setup is in the diagram. In this example, we're given that triangle ABC and triangle EDC are similar. And so kind of like with congruent triangles, it's not a bad idea, let's use our diagram to our advantage. So if we're looking at triangle ABC, I want to think of tracing through A to B to C, and then triangle EDC, again, starting from E to D to C. So you'll notice these triangles are actually twisted around and technically reflected from each other. So multiple things going on here. Sides that are congruent, not congruent because we have similar triangles, so they are proportional. Our sides that are proportional, we could compare A to B over ED, which again, I'm noticing in my names. And if I'm a more visual person from the diagram, just from the order of the arrow that I drew through, that's going to have the same relationship as BC compared to DC. And that's the same relationship as CA compared to CE. And we could take any two of these ratios, set them equal, and create a proportion that we could then solve. Our angles, keep in mind with similar triangles, our angles are always going to be congruent. So I could say that angle A is congruent to angle E. And again, notice in the name, those letters are in the same spots. We have angle B is congruent to angle D. But in the names, angle C and angle C, I know they're two different angles, so I do need to use my 3 letters on this. So let me change my color. So if I go in the same order of the triangles, I'm just kind of continuing my order. Or I could go based on the names. So if I name the first angle, again, I'm looking at the C angles that are in the middle, so I need to make sure that C is in the middle of the name. Let's go with the first one, BCA. So if I use the order that they gave me on the triangles, B to C to A, so do the same thing in the second triangle, D to C to E. So again, always use that similarity statement to your advantage. Now we can also keep an eye on, well, which pieces are we comparing? It doesn't make sense to compare the smallest side in one triangle to the largest side in the other triangle. So you can always use that as well to match things up. Alrighty, so example 2. If the figures below are given and they have a scale factor of 2 to 3, we need to find the solution for X. And so I already have one ratio, it's just in disguise. This scale factor 2 to 3, I can use that as my first ratio. And then it also gives me an idea, if I'm going 2 to 3, I'm going to small to big. I need to take the piece of information from my smaller triangle, which in this case is the 42, compared to the X. And then we cross multiply and solve it out. So 2 times X is going to equal whatever 3 times 42 is, which comes out to be 2, gives us 126. So our answer for X is just half of that, which is 63. Okay, same thing for example 3. We're given our scale factor 6 to 5. So if I start with that, I'm going big to small. So what should our second ratio be written as? Big triangle first means I'm looking at the X compared to the 28. And again, these are flipped around and I didn't have any other sides to compare, so I know I only have enough info to use the X and the 28. But noticing in both of those triangles, those are labeling the longest side on those as well. So that's another indicator, hey, I picked out my correct corresponding sides. Okay, cross multiply, again, we're gonna get a 5 times x, and then 6 times 28, which comes out to 168. And so this does give us a decimal, that's okay, that happens. So divided by 5 will give us 33.6. And you will start getting more and more decimal answers. If we think about, possible application problems coming down the pike, in other words, we're using math to describe real life. Real life is never pretty, so sometimes our answers won't be either. All right, let's look at some more diagrams again. We have to pay special attention to our order on these. So example 4 and example 5, you'll notice with both of these, now we have multiple things labeled. We really need to rely on those names. So example 4, triangle AGM is similar to triangle KXD. So pick a side and see what it matches up with. So if I start with a 32, that's side GA. So look at your diagram, your similarity statement. GA or AG, those are the first 2 letters. So I need to match it up with the first 2 letters from the other triangle. So that's segment KX or segment XK, which is this one. So that means my 36 will have to match up with my X plus 6. And when I write my ratio, I just need to make sure I'm always going in a consistent order. So if I start with the left triangle or the smaller triangle or however you see it, always start with that triangle. So if I start with 32 and compare that to the side in the other triangle, the X plus 3, well then I need to go in the same order. So start on the left-hand triangle with the 36 and then compare that to the X plus 6. And now we just cross multiply and solve. So we have a 32 times X plus 6 and a 36 times X plus 3. And again, I would always suggest writing out the full proportion and then solve things out. So then distribute out your 32. So 32X plus 32 times 6, AKA 192. And 36X plus 3 times 36, which gives us a 108. Now combine your like terms. So I'm going to subtract the 32X from both sides. So that will give me 192 equals 4X plus 108. And then subtract 108 from both sides. So 192 minus 108 gives me 84. And it's okay that my X is on the right-hand side of the equation, whatever works. And so divide that out and I get 21. So X equals 21. Okay, go ahead, pause the video and try writing out your proportion for example 5. Okay, let's see what you matched up. So again, just pick a random side to start with. I'm going to start with MP. So if I'm looking at my names, MP, those are the first and the last. So I need to match it up with the first and the last in the other triangle. So that means QP, which is segment 28. Okay, so 24 compared to 28. And then I started on the left-hand triangle, so X plus 8 over 3X minus 9. Same as always, write out your full first step. So 24 times 3X minus 9 equals 28 times X plus 8. Distribute out. 24 times 3 is giving me a 72. And 24 times 9 is a 216. So we are getting some larger numbers on our examples today, but that's okay. Let's see, 28 times 8 gives me 224. Okay, combine your like terms. So I'm going to subtract a 28x from both sides. Gives me a 44x. And then add 216 to both sides. 224 plus 216 gives me 440. Ooh, that math works out wonderfully. Divide both sides by 44, and we get out a 10. Alrighty, so sometimes we're actually going to have, some overlaps. Actually, looking ahead, example 6 doesn't have any overlaps, but it does have two variables to solve for. So the only thing about number 6 is that we just have 2 variables. So, but now we have every single triangle side labeled. So again, be careful of your names. Now in this scenario, we are going to have to set up 2 proportions, one to solve for the X, one to solve for the Y. And let's just start out with matching up corresponding pieces. So our 40, JK, first 2 letters, should match up with NM, which is the 16. Okay, the 45, JL, first and third, so he should match up with NL. And then our leftovers match up. Now in each problem, we want to start with a scale factor or a ratio that just has numbers in it, because I know I'm trying to solve for both variables. I only want one variable in there at a time. So my first proportion I'm going to set up is 40 compared to 60 equals X compared to 14. Again, pick what triangle you're going to start with and always start with that triangle. Okay, cross multiply, we get a 16X equals 40 times 14, otherwise known as 560. Divide out by the 16 and we get a 35, which makes sense for that triangle. We have 40, 45, and 35. We have a larger side to make sense with that. So thinking about that, when I get my answer for Y, I should definitely be getting a smaller number, because if he's on the smaller triangle, I should be getting something that's a little closer to 14 and 16. Okay, I'm still going to start though with my 40 over 16, and I could always reduce that down if I wanted to, but if I'm using a calculator to check my work, you know, either way would be fine. Alrighty, so same thing, left triangle to right triangle, so I'm going to go 45 over Y. Cross multiply, I get a 40Y equals 16 times 45, or 720. And then divide both sides by a 40. Should come out pretty nice. Yeah, that one comes out as 18. There we go. Okay, then 7 and 8 are a little different. So we do technically have 2 triangles in disguise, but what's happening is we've got a smaller triangle overlapping a larger triangle. So a lot of times in these cases, I find that I either have to label the diagram very clearly, or I want to redraw my 2 triangles. So in this case, I already have my small triangle, and let's do this by actually redrawing our triangle. So I have my small triangle ADE, which already has 2 sides labeled. And so then I need to look for my big triangle. So triangle ABC. And I'm noticing that on the top piece of that, I have both the 20 and the 8 labeled. So what does that mean the entire top side is going to be? So actually, let's move that over. Let's see, will you let me select? Hey, looky there. So I'm going to redraw that red triangle. Actually, let's draw it below. It'll fit a little bit better down there. And so that's triangle ABC. I know the right-hand side is 2x plus 3. And the top side, I have to put together the 20 and the 8. So I'm going to get a 28. And so now I can just treat the blue triangle and the red triangle as similar triangles. I can double check against my names just to make sure that I'm comparing the right pieces together, but I'm ready to write my proportion. Okay, so 20 side AD should match with side AB, 20 and 28. Okay, I don't really have a shortened piece up there to match it up with, so I'm not going to use that 8 anymore. But my leftover sides, I have a 15 on the small side, that's DE. So that's going to have to match up with BC. So that's this guy. Excuse me. So here we go. So 20 compared to 28 equals 15 compared to 2x plus 3. And then we just cross multiply. So 20 times 2x plus 3 equals whatever 28 times 15 is. That gives me 420. So then distribute out your 20 on the left-hand side. We're going to get a 40x minus, I believe that's 260, but never a bad thing to check. Add your 260 to both sides. So we'll have 40x equals 260 plus 420 equals 680. And then divide both sides by 4. Again, we should get a pretty nice number out of there. 17. Awesome. So again, if it helps, redraw your triangle. I know you probably don't have fancy tech like I do where I can just take my drawing and shift it over. But if you have any loose leaf paper, it's usually thin enough that you could trace things through if you want. Okay, let's try example 8. I believe this is our last one. And again, we've got an overlapping triangle on here, but let's think about that information. So we have our smaller triangle. And again, I'm going to go ahead and trace them over. And then we have a bigger triangle, YSZ is our smaller triangle, RST is our big triangle. So I'm going to go ahead and trace over this again. So here's my red triangle, and then let me pull that off to the side and relabel it. So pulling that over. Okay, so that gives me triangle RST, and it had the entire side 40 labeled, and we had a 3x minus 7 on the bottom. So I know everything for my red triangle, but what about my blue triangle? So for my blue triangle, looks like I have a label on the bottom. I have the 2x plus 2, but what's going on with the right-hand side? Well, if I know the whole thing is 40, and we're given this small piece down at the bottom, which is 5, that means my leftover kind of top piece, the right-hand side of that blue triangle, that's going to have to be, just subtract them, that'll have to be a 35. So now I have all the info I need to write this out. Okay, so now would be a great time to pause the video and see if you can come up with a proportion before you check your work. Okay, let's see how you did. So we have, I'm going to start with a 2x plus 2. So bottom side to bottom side, I'm going to compare that to 3x minus 7. So then right side to right side, 35 to 40. And again, this isn't the only way to write out your proportion, but you should be able to do this with your proportion if you tried it in a similar fashion. So if you look at the pieces that you're cross multiplying, you should have your 3x minus 7 and your 35 diagonal from each other. And then you should also have your 2x plus 2 and your 40 diagonal from each other. So even if your proportion is written slightly differently, you looked at it in a different order, as long as the same things are diagonal from each other, you are good to go. So let's go ahead and solve this out. Cross multiplying, I'm going to do, oops, let me get the blue. I know it's a little easier to see. So we're going to do 40 times 2x plus 2 equals 35 times 3x minus 7. That's another way that you can check your work. If that second step, when you write out what you're cross multiplying, if that matches up, even if your proportion doesn't, then you still know you had a correct setup. Okay, 40 distributed out, we have an 80x plus 80, and then distribute out the 35. So 35 times 3 is giving me 105. So 105x minus 35 times 7, or 245. Okay, combine your like terms. I'm going to subtract 80 from both sides, or rather, I'm going to subtract the 80x. And you'll notice whenever I do these, I'm moving my x over. I'm not really paying attention to what side it ends up on. I'm just trying to keep it as a positive coefficient, because that just means in the end, I'll have fewer steps. Okay, now I'm going to add 245 to both sides. I get 325, which should be divisible by 25. So we should get a nice answer on this one. We get x equals 13. So not necessarily the luckiest answer, but we have a nice integer answer. Alrighty, as always, do let me know if you have any questions. I do have some videos posted on the Extra Help video site as well if you need to see more examples, or pop back into Zoom to ask me whatever questions you need to, whether it's now or as you're into your activity. Talk to you later.